All right, let's talk about aqueous solutions. So, an aqueous solution just means that whatever we're talking about is dissolved in water. And the way we phrase it is that the solute dissolves in the solvent to form a solution. In the case of an aqueous solution, the solvent is water. So, solute plus a solvent gives you a solution. You're going to hear the term electrolytes. That just means solutes that form ions in solution. There are two types, strong and weak, and this has to do with how completely they dissociate in water. So a strong electrolyte will completely dissociate in water, and a weak one will only partially dissociate. And then non-electrolytes don't form ions. So if you're not sure where something falls in the electrolyte chart, you can follow this handy-dandy flow chart. So the first question is, does the solute form ions in solution? If it doesn't, then that's a non-electrolyte. For example, sucrose. Sucrose can dissolve in water, but it doesn't form ions in solution. If it does, then you have to ask, is it ionic? So is it an ionic solute, or is it a molecular solute? If it's an ionic solute, then it's a strong electrolyte. So all salts, all ionic compounds are strong electrolytes. Now, there's a little bit of contention here because there are some ionic compounds that have really, really low solubility constants, so they don't dissolve in water very well. But when they dissolve in water, they 100% break up into their ions. So sodium chloride would be an example of a strong electrolyte that's ionic. If it's not ionic, then you have to ask the question, does it completely dissociate in solution? Yes or no, and this is where you'd say, okay, if I put hydrochloric acid in water, it will completely break down into protons and chloride ions. But if I put acetic acid in solution, then it will break down into protons and acetate ions, but most of it stays together as acetic acid molecules. So if it does, then that's a strong acid, like hydrochloric acid. And if it doesn't, then that's a weak acid or a weak base, and those are your weak electrolytes. So the weak acids and bases, weak electrolytes, are not ionic. All your ionic compounds are going to be strong electrolytes. And the way this plays out is you can put a light bulb in a solution, and if it lights up, you're powering a powered light bulb with a broken circuit. You put the circuit in the water, and if it's a strong electrolyte, it'll light up. If it's a weak electrolyte, it'll light a little bit. And then if it's a non-electrolyte, it won't light up. So water, natural, pure water, does not conduct electricity very well. It's dissolved solids, dissolved electrolytes that give water its conductivity. So aqueous solutions involves a whole lot of different reaction types. So we're going to devote a video to each different reaction type, just so you can get an idea of what's going on. But this term of electrolytes is somewhat of an important one when we're talking about aqueous solutions.